Have you ever thought if a normal looking image could secretly contain another file, not encrypted, not zipped, actually hidden inside the image itself? That's called steganography, and today I'm going to show you exactly how it works using a Linux tool called Steghide. We'll install it, hide a file inside an image, compare the image before and after, extract the hidden file, look at some useful commands, and even see what happens if we enter the wrong password. Everything shown here is for educational purposes and should only be used on files you own or have permission to work with. So let's get started. Step 1. Installing Steghide. Now, how do you install Steghide on Linux? Just open up your terminal and write down sudo apt update. After the completion of the update, write down sudo apt install Steghide and press enter. This command will download Steghide into your Linux machine. And then we are good to go. Once the installation finishes, let's verify it. Steghide --version. This confirms that Steghide has been installed successfully. For this demonstration, I have two files. The first one is my cover image, secretimage.jpg. This looks like a completely normal JPEG image. The second file is hiddenmessage.txt. This contains the secret message that I want to hide. The image is around a few KBs. The text file is only a few bytes. We'll compare these sizes again after embedding. Now comes the fun part. We'll use the embed command to embed our hidden message inside our secret file. Steghide embed -cf secretimage.jpg -ef hiddenmessage.txt. Let's understand these options. Embed. This tells Steghide that we want to hide a file. -cf means cover file. This is the image that will carry the hidden data. In our case, secretimage.jpg is our cover file. -ef means embedded file. This is the file we want to hide, hiddenmessage.txt. After pressing enter, Steghide asks for a passphrase. Choose something strong. You'll have to enter it again for confirmation. After that, Steghide modifies the image and embeds the hidden data. Now let's compare the file. You may notice the file size has increased slightly. That's because our hidden data has now been stored inside the image. Visually, the image looks exactly the same. There are no obvious changes. This is one of the biggest advantages of steganography. The image still appears perfectly normal. Now imagine someone knows this image contains hidden data. How do they recover it? Using the extract command. Steghide extract -sf secretimage.jpg. Let's understand these options. Extract means recover hidden data. -sf means stego file. In other words, the image that already contains the hidden information. After pressing enter, Steghide asks for the passphrase. If the password is correct, the hidden file is extracted successfully. Let's confirm. Cat hiddenmessage.txt, and there's our secret message. Now let's try something else. I'll enter the wrong password. As expected, Steghide refuses to extract the file. Without the correct passphrase, recovering the hidden file becomes significantly more difficult. If you ever forget a command, simply run Steghide --help or man Steghide. These show all available options and detailed documentation. Now the question which will come in your mind is, can it be detected? Does that mean it's impossible to detect? Not necessarily. Digital forensics tools and steganalysis techniques can sometimes identify suspicious files depending on how the data was hidden. So Steghide is not magic. It's simply another cybersecurity tool used for learning, research, and legitimate data hiding. And that's how you use Steghide to hide and recover files inside an image. If you learned something new today, consider subscribing, because this channel is all about beginner-friendly cybersecurity, Linux, networking, and ethical hacking. Thanks for watching, and I'll see you in the next video.